Here is Richard from a company who's already working on this.
Yes, and thank you, Magnus, and thank you, Ted and Karin, for setting the table here, or setting the background a bit. It's really appreciated, and I think everyone has now understood how big space is and the opportunities connected to that. And I'm invited here to present Unibap as a company and a bit what we're doing, but I'm trying to do it in a bit of a different way than just a classic company presentation, and rather focus on what we're doing and what we're enabling. So Unibap, which I'm working for, what we are really trying to do is we're trying to enable time-critical, actionable information made in orbit being available on Earth. That's actually the end target and what we're trying to achieve. And we'll go through a bit how we're doing it and the journey to get there. Unibap as a company, why we are unique, we are really in the forefront of developing a new space economy. And what we are doing and the part we're trying to fill is within edge computing. So the key expertise within Unibap and what we are contributing with is actually edge computing. And that includes both on Earth. So we have actually an industry leg I will not spend too much time on, but more specifically on where we are growing fast now in orbit. Looking upon that then, what are we doing? And to make it very simple, because normally when you try to present something like this, it will get very advanced and I will have to spend more than 10 minutes. But in simple words, what we have done is we have taken an Earth computer. The one that we currently have up and circulating around Earth is similar to PlayStation 4. And we have adapted it so it actually works in space. And it sounds very easy, perhaps, but it's extremely hard because in space, the environment is not that friendly. And you need to handle a lot of different things, such as radiation, and in example, then excess heat or low temperatures. And what we have enabled with this, and it's quite unique, is that when you have a computer in orbit, you have a server suddenly, you can actually update the abilities of the satellite in orbit. So actually you can update the computer. In addition to this, we don't only have a computer, we actually have a software platform. So we have an operating system and a framework so that's easy to develop something on the computer. What is quite common today in the space industry is that it's built up in verticals. This is an industry that loves engineering, so everyone wants to do it themselves. But long term, and when this is growing, we don't think this is the way to do it. We think that rather building an open platform to be able to scale is the way to do it. So we are building a computer that any constellation or any satellite developer can use as part of their platform, and also software developers can develop an app that can be sold on this platform or to be compatible with the platform. And we think this is the way to go and the way to scale in this industry moving forward. And the reason to have a computer in space is, in short, that it enables actionable data to be sent down to Earth really, really fast. And why is this? What is the reason? What is driving this need? The challenge in space today, one of the big challenges, it's around actually how do you transfer the information from space to Earth? And it's not that simple that you have a high-speed internet that you're always connected to the satellite. It's actually one of the big bottlenecks in space today. How do you get information down? If you want to get it down really fast, you probably need to be the US to have top priority and a lot of downlinks available. But normally you will end up in priority issues and you need to find a ground station available. And the more data you have, the more challenging it is. And the smaller company you are, the more challenging it is. And you can say the faster the data update speed you have, you rather end up being a nation or the US in the end today. Next part of this is that even if you have access to data, it's something extremely expensive. So if you look at a satellite mission today or a constellation, a big chunk of the money to be invested will be connected to the bandwidth and communication of this. It's part of licenses, it's priority on how fast you need the data. But in the end of the day, this is major money. Can often be half the value of the satellite, at least per satellite. Next part of this, and what often happens in the industry, is that when you end up in verticals today, many times one satellite would be developed for one purpose. And this is, of course, not that efficient because it's a limitation how many satellites can be sent up per year. And it's also a huge investment to make one launch. One of the abilities when you have a computer up there is actually you can task the satellite to do different things depending on where it is in the orbit. So it could look for forest fires in one instance, and then the next instance it can, in example, supervise a volcanic eruption or something like that. So you can have multi-purposes for one satellite and share the investment. And last but not least, today, in many times to survive in the harsh environment, you would use something like an FPGA solution. And that is quite complex. It's in theory perhaps possible to do in orbit and update on it, but in reality not. So normally before you send up the mission, you need to design the purpose. And if something would be wrong, you cannot update it. With a computer up there, you can actually update in orbit, you can change purposes, you can improve the models, and you can apply AI models that are reasoning in space. So an example, you can even have several satellites combining their knowledge to improve. And one example of an application that could be of interest is that you have one satellite that looks really, really broad to detect, in example, smoke. And the next satellite can know, okay, we see smoke, we should look closer if it is a fire or not. That could be an example how you can use this. So this really opens up some new possibilities. What have we then shown? Because we are proven in space, which is quite unique for this kind of solution. We have shown that actionable information using inter-satellite communication can be sent down to Earth between 1 and 3 minutes. I think a lot of people have heard about working with space data, Copernicus, and then normally we're talking about weeks to get an update of the data. Here, if you have a constellation, you can go down to 1 to 3 minutes and have actionable information. Next part, and this is really connected to cost and in reality also speed, because you need less of bandwidth. Instead of sending down all information, all the pictures, that is a common way of doing it today, you can send down the actionable information. We have shown in practice some example with water, how water is spreading out, that we can use an application with an AI application, we can reduce the actual data needed to be sent down with 99.9%. Next part of this is, since you can have several applications on the computer, you can increase the utilization. In a concrete case, in our current computer, you can actually run what we have proven so far, 30 applications in parallel. So you can split the cost between 30 use cases. And last but not least, and I think this will be a very important thing, you can deploy a new application or a new use case within a week, instead of today when you need to do something new. Many times you need to design a new mission and it's at least 6 to 18 months away and in a totally different investment scale. So this is really what we're doing and what we are contributing with. And we think edge computing will be the new thing in space, because it's one thing that would remove a major bottleneck for the industry to move forward. What is then driving this? Of course, like everything in space, defense is one of the key drivers in technology. And you can imagine, as an example, in Ukraine right now, if you can get the coordinate for every tank or every air defense system every 3 to 5 minutes, that would be amazing. That could be a possible application. As Ted said before, agriculture is a major driver in this area. And if you can get really, really fast updates, you can know today is the day to put on, add watering or add fertilizers and so on. And last but not least, critical infrastructure is a strong driver. I think the pipelines outside of Sweden blowing up is a concrete example to supervise these, or for storms, figure out where the damage is, are major use cases with big investments possible. But in reality, with the computer up there, with AI in the computer, it's just imagination that will set the limit. And I don't think we even know the biggest use case today. Last but not least, I mean, what is unique with Unibap and what we have done is that we have actually proven this. It's a lot of companies that are talking about it, but we have proven it in our orbit. And we have a lot of different applications that are proven. Some examples here is the World Flood app, that is the concrete case where we demonstrated a 99.9% data reduction. We have looked on ship tracking. We have been able to track airplanes. But I think in reality, what this is all about is you can reduce the amount of data sent down, starting with a very simple case, removing clouds, to a very advanced case, looking for missiles or looking for airplanes. And when I say proven in use, we have several missions with our customers, and normally they are confidential, so I'm not allowed to talk about the majority of those. But what I can say, we have 2 concrete missions we have been part of ourselves with the help of a lot of different organizations sent up with the orbit. And here is where we have demonstrated the technology, and our computer is currently on a TRL 9 level, which is really what make us being able to say proven in space in 2022. And since I had a limited amount of time, I don't have to talk about the specific cases, but just the last month, I would say, thanks to the maturity level of the computer, and I would say the industry is really accepting this and screaming for the solution, we have a lot of things going on. And this is just actually from the last 3 months. We have a number of, I would call it volume orders to satellite constellations or large companies that are now buying these for technology proof and being part of the next constellation being planned. In addition, it's not only about the hardware, as I said before. We can see that the software side of the business is also interested in what Unibap is doing. Really happy that we were able to announce that part of one of the missions here was that Amazon Web Services wanted to demonstrate their technology. And this is one of the companies we're collaborating close with. So I think looking on how small we are, it's quite amazing to see what kind of companies we are collaborating with and that they are seeing the value of this technology. And who are we then? I mean, it sounds like we are the biggest company ever, but we are actually a relatively small startup. I would say maybe now we are allowed to call us a scale up. We are a spin-off from a university environment, 2013. With 3 professors working with industrial automation, artificial intelligence, and space. And I think this is really the secret to the company, that we are combining different technology together and made something revolutionary new in the industry of space. So moving away from the FPGA thinking to the computer thinking and making use of what AI can do. Aside for that, we can say that we are on Nasdaq First North, so we are a publicly listed company. We have approximately 50 talents in the company today, growing fast, and we are really scaling up, as you can see on the press releases I just showed. We are in space since 2016. We have a computer called iX5, which is proven since this year, and we have just actually sold the first of the next generation computer called iX10. So we are moving from the PlayStation 4 generation to the PlayStation 5 generation of the processor, you can say. I hope I managed within the time frame here. I condensed it a bit, Magnus, to just give us a teaser of what Unibap is doing and the abilities we're opening up.
It's great.
Thank you very much.
Yeah, it's great, Richard. Thank you so much. I think your story remains amazing. So, every time I hear it. So thank you so much for sharing this with us.